So in the previous video, we talked about deleting an element in single linked list from its beginning. Now let's talk about deleting an element from the single linked list from its end. So now I am going to write delete E operation from the end. And what should I do? So just like before, I should check if there is anything in the list to delete. So this particular block, it will be common. Okay, so I'm going to check if my list is empty. If it is empty, I'm going to throw error. Okay, so that would be directly copied here. Okay, so once that happens, so I won't rewrite that again. I will assume that you can put that there. So after that, what I really need to do is, if this is my single linked list, let's say with 3 nodes, when I want to delete the last node, the second last node, it should become the last node, and then this should point to null. That's the way my list should change. So what I really need is not the pointer to the last element of the list, but I need a pointer to the second last element of the list. Okay, but before we go there, we need to handle a special case when the list has only one element, because in that case there will be a last node but there won't be a node before it. Okay, so now we have taken care of ensuring that the list is not empty. Now let's handle the case when the list has just one element. So if my head dot next is equal to null, what does it mean? I have the head pointer and I look at the next, it's null. That's what tells me that my list has just one element. Okay. So if my head dot next is equal to null, that's the case where list has just one element and I need to delete that element. So my list should become null. So what I would do is I would say that my answer is equal to head. I will store the address of the first node, and then I would say that my head should be null. Okay, and my head becomes null, and then I will return the answer. Okay, so this is a case that takes care of single element present in the list. And now let's think about the general case when list has more than one element, say 5 elements, 10 elements. In that case, I have to traverse the list right from the beginning, and I have to reach the element just before the end of the list. So second last element I have to reach. So what I will do is I will start with a pointer called current. Let it point to the first element in my list. And then what I will do is I will keep on moving within the list. So I'll put a while loop. I need a looping construct. I will have certain condition. Okay, we'll write that condition. But what I basically need to do is look at the current and move it to the next pointer. So it should be cur dot next. And you keep on doing this. How long you should do this? Till you reach the second last node. And what is the characteristic of the second last node? Well, when you are pointing to the second last node, if you look at the current dot next, it gives you the last node's address, and for that particular node, if you look at the next, the answer is going to be null. Okay, so while this answer is not null, we should keep on moving further in the list. Okay, so I'll just tell it again. With this looping construct, we are moving in the list one node at a time, and we want to stop when we encounter a node such that when I look at the next node after the current node, and for the next node when I look at the next, I'm getting null, which means that after this node there is one more node, but after that the list terminates. That's when I will break out of the loop. So now I am pointing to the second last node in my list, and now what should I do? I know my answer. My answer is going to be current next. Okay, and then I have to remove the last node from the list. So I would simply say that my current dot next is going to be null. It should not point to anything. I am making current as the last node, and then I should return my answer. Okay, and then I'm done. Okay, so let's try to execute this on first of all an empty list. So let's say this is my list L. It has the head pointer, and right now it points to a null. In this case, when I call delete from the end, what is going to happen is I'm going to check if my list is empty, head points to null, so this condition will come out to be true. I'll return error and I'm done. Okay, so none of this part would come in picture. Okay, so that's delete element from the list from the end when the list is empty. Now let's have a case when I have just a single element in my list. Okay, let's say I have 10 here and then there is nothing else. In that case, what is going to happen is when I enter this function, this particular condition is going to be false. So I'll skip this condition block. I'll come here. I'll check if head pointer head dot next is null, which is going to be true here because head points to this node, and for this node next value is null. So this condition comes out to be true. I come inside the conditional block. My answer would be head. So this is going to be my answer. The address of this particular node is going to be my answer. And I would say that now head is null. So this head, instead of pointing to this node, now my head would point to null. So effectively this particular node is now removed from the list. Okay, and then I'm going to return back the answer. So I'm going to skip this rest of the code. Okay, so that's how deletion of a single node happens when you are deleting it from the end. And now let's take a case where my list has not just one node but multiple nodes. So let's say I have 10, 20 and 30. Okay, and then let's say this is the last node in my list. So what will happen is first this particular condition will come out to be false, even this condition will come out to be false, and now I will say my current node is the head node, which is the node 10. Currently answer has no value defined, so my head is 10, and then is current pointer next. So current next, is it null? It's not null. If this condition evaluates to be true, I have to go inside and I would say that my current is going to be current.next. So now current would point to 20. Okay, and I come back and ask this question, is it true? So current dot next, but now it is null. So this condition not equal to is not satisfied. So I will break out of this particular loop. And now I will say that my answer is current.next. My current was 20, so current.next is 30. So address of this node would be stored in my answer. And now current.next would be null. So 20 is the current.next. Instead of pointing to 30, now this will be a null pointer. And effectively 30 is now removed from the list. And now my list is head, which is 10, and then 20. It is reduced to only 2 elements. And then I'm returning answer, which is the pointer to the last node, address of the last node, which can be used in any way by the client program. Okay, so that's not up to us to think right now. Okay, so that's about deleting an element from end of the list. And let's see what is the time complexity. Okay, so if list is empty, we can finish in constant time. If list has just one element, we can still finish in constant time. However, if list has more than one element, in that case I have to traverse the list. Okay, I have to traverse from the beginning up to second last element. So that involves traversing n. So if list has n elements, involves traversing n minus 1 elements, which means I require effort which is of the order of n. So if there are n elements, I require theta n steps to complete this while loop. So in the worst case, what is going to happen is if my list has n elements, deletion from the end would require theta n effort. So deletion from the end belongs to theta of n. It's linear time.